Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today I came up with another variety of the transportation problem. So let us quickly move on to the question. So the question says a steel company has 3 open furnace and 5 rolling mills. Transportation cost per rupees per quintal for shipping steel from furnace to rolling mills are shown below. What is the optimum shipping schedule? So here in this matrix we have given 3 furnaces F1, F2, F3 and 5 rolling mills, and the transportation of steel from furnace to rolling mill is given in the form of unit transportation cost, and the supply and demand are also given. So first of all, in any transportation problem, what we will like to know is whether our problem is a balanced problem or an unbalanced problem. So let us quickly see if our problem is a balanced or unbalanced problem. So here the supply is 8 plus 12 20 plus 14 34, and the demand are, this is 10 plus 14 and 8 22 plus 6 28. So as we can see that the supply and demand are not equal, so this is an unbalanced type of problem, and in order to balance this problem, what we'll do is we'll see that the demand is deficient, so we will add a dummy column which will show the demand equal to the difference between these two, that means 34 minus 28. So I have already prepared a matrix where we have shown a dummy column having the demand as 6. So now if we see the supply is equal to 34, and by adding demand this is also coming up as 34. So now our problem has been changed into a balanced problem, and first of all what we'll do is we will find out the basic feasible solution for this particular problem, and afterwards we will check for optimality whether our solution is optimal or not. So let us start with finding the basic feasible solution. We will find the basic feasible solution by Vogel's approximation method, or we can call it a penalty method. In this method we will calculate the penalty, which is the difference between minimum value and the next minimum value in each row and in each column. So quickly calculate. Here in this column minimum is 4, next minimum is 5, so penalty is 1. Similarly here minimum is 2, next minimum is 4, penalty is 2. Here minimum is 3, next minimum is 4, penalty is 1. Here minimum is 2, next minimum is 2, penalty is 0. Sorry, penalty is 0 here. Here minimum is 1, next minimum is 3, penalty is 2. Here minimum is 0, next minimum is also 0, so penalty will be 0. Now moving on to the column, we'll see that minimum is 0, next minimum is 2, so the penalty is 2 here. Similarly here minimum is 0, next minimum is 1, penalty is 1. Here minimum is 0, next minimum is 3, so the penalty here is 3. Now we will select the row or column with maximum penalty. So here we can see that among all these, 3 is having the maximum penalty, so we will select this row, and in this row we will select the cell which is having the lowest transportation cost. So this particular cell is having the transportation cost 0. So what we will do is we will select this cell and we will try to allocate as much as possible in this particular cell. So we can see here that here the demand is 6 and the supply is 7, that means out of 14 6 can be fulfilled here. So we have made 6 here, that means now this will become 0 and this become 8. Once this has been fulfilled, that means no other allocation can be done in this particular column. So we will cross it out. Now again we need to calculate the penalties. So as we can see that columns does not change, so the penalties in the column will also not change, and we will need to calculate the penalties in row. So here we can see that penalties in row. Now the minimum is 2, next minimum is also 2, so the penalty here has now become 0. Minimum is 1, next minimum is 2, penalty here is 1. Minimum is 3, next minimum is 4, so penalty here is 1. Now let us see that among these there are two values, 2 and 2, which are the maximum penalties. So we can select any one of them. So let us select this one, and in this one we will select the cell which is having the lowest transportation cost. So here this cell is having the lowest transportation cost. That means we will try to allocate as much as possible in this particular cell. So we can see that here the supply is 8 and the demand is 4. That means out of 8, 4 can be fulfilled here. So this will become 0 and this become 4. Now once this has been fulfilled, that means no more allocation can be done in this particular column. Now again we need to see that in the rows, these 4 rows does not change. That means penalty in this row will also not change, and these two are eliminated because the demand has been fulfilled, and we need to calculate the penalties for row again. So for row, minimum is 2, next minimum is 3, so now this will become 1. Similarly here minimum is 1, next minimum is 2, so penalty is 1. Minimum is 3, next minimum is 4, so penalty is 1. Now among these, this is having the greatest penalty, so we will select this column, and in this column we will select the minimum transportation cost cell. So this is the cell, and we will try to allocate as much as possible in this particular cell. So here the supply is 12 and the demand is 6. That means out of 12, 6 can be allocated, and once 6 is allocated, this will be 0, and no more allocation can be done in this particular column, and this will be reduced to 6. Now again we will calculate the penalties. So as these 3 row does not change, the penalty will also not change, and this will be removed because now the demand has been fulfilled. So again we will see that the penalty for this row is minimum is 2, next minimum is 3, penalty is 1. Minimum is 2, next minimum is 5, so the penalty here becomes 3, and here minimum is 4 and next minimum is 6, so the penalty here becomes 2. So now we can see that maximum penalty is having here. That means we will select this row, and in this row we will select the cell which is having the lowest value. So this is the active cell which is having the lowest value 2. So we will try to allocate as much as possible. So we can see that demand here is 8 and the supply only 6 is remaining. So out of 8, 6 can be fulfilled. So we will allocate 6 here, and this has been reduced to 2. This has been reduced to 0. So once this has been fulfilled, that means no other allocation can be done in this row. Now again we need to calculate the penalties. So let us calculate the penalties for rows and column. Here minimum is 4, next minimum is 6. The penalty here is 2. This has been fulfilled. Here minimum is 3, next minimum is 4. So penalty here is 1. Here minimum is 2, next minimum is 7. Penalty here is 5. This has been fulfilled. This has been fulfilled. Now moving on to the row. minimum is 2, next minimum is 3, so penalty here is 1. Okay, minimum is 4, next minimum is 6, so penalty here will be 2. Now let us see that among these 5 is having the greatest penalty, so we will select this column, and among these two we will select the cell having the lowest transportation cost, and we will try to allocate as much as possible here. So here we can see that the demand is 2 and the supply is 4. That means 2 can be easily allocated here, and this will become 0. So no more allocation can be done here. Similarly, out of 4, now only 2 is remaining. So now we will again calculate. So as the columns does not change, the penalties also does not change, and this will get eliminated because the demand has been fulfilled. And in the rows we can see that minimum is 3, next minimum is 4, so penalty is 1. Here minimum is 4, next minimum is 6, so the penalty here is 2. Now we can see that there are two same values, that is 2, having the maximum penalty. So let us select this 2, and here we will select the cell which is having the lowest transportation cost. So this is the cell, and we will try to allocate as much as possible here. So we can see that 2 is the supply and 4 is the demand. That means out of 4, 2 can be allocated. So I have allocated 2 here, so this will become 0, and no more allocation can be done here, and this has been reduced to 2. Now we can see that only one row is left. That means we do not have any choice now, and we need to put the remaining allocation in this cell only. So we can see that out of 2, 2 has to be allocated here, this will become 0. Out of 6, 6 has to be allocated here, this will become 0, and this will be 0 because 2 plus 8 is 0. Now this is our basic feasible solution, and I am just erasing this. So this is the basic feasible solution we have obtained from Vogel's approximation method. Now let us see if this basic feasible solution is optimal or not. So let us write the allocations here. So this is 2, 4, 2, 6, 6, 2 and 6, and this will be 6. So we can see here that the total number of allocation is 1, 2, 3, 4, 5, 6, 7 and 8, and m plus n minus 1 number of allocation should be m is 3, n is 6, 3 plus 6 minus 1, that is 8. That means we have exactly m plus n minus 1 number of allocation here in our basic feasible solution, and now we will try to check whether this solution is optimal or not. So we will check this by modified distribution method, or we can call it MODI method. Now in this method we will see that we need to calculate various variables u1, u2, u3, v1, v2, v3, v4, v5 and v6. Now as we know that for allocated cell the value of Cij, that is unit transportation cost, is equal to the summation of ui plus vj. That means if I take this value as 0, so 4 is equals to 0 plus what, or I can say 0 plus what equals to 4. So this will be 4. Similarly, we will calculate the values of other variables through allocated cells only. So let us try 0 plus what equals to 2. So 0 plus 2 equals to 2. Here also 0 plus what equals to 2. So this is also 2. And we know that this is 4. 4 plus what equals to 6. So 4 plus 2 is 6. Similarly, 2 plus what equals to 4. So we can know that 2 plus 2 is 4. Here 2 plus what equals to 0. So 2 plus of minus 2 is 0, and here we can see that 2 plus what equals to 2. So 2 plus 0 is 2, and 0 plus what equals to 1. So 0 plus 1 is 1. So from the allocated cell we have calculated the values of all the u's and v's by putting one value equal to 0. Now we need to calculate the value at non-basic cells. So what we are going to calculate here, we are going to calculate the value of Cij minus of ui plus vj. Okay, I am writing it here, Cij minus of ui plus vj. This is we need to calculate for non-basic cells. So here we can see that 3 minus of 0 plus 2, that means 3 minus 2 is plus 1. Here 6 minus 0 plus 1, that means 6 minus 1 is plus 5. Here 0 minus 0 minus 2, minus of minus 2 is plus 2, so this will be plus 2. Here 5 minus 0 plus 4, that means 5 minus 4 is plus 1. Here 4 minus 0 plus 2, 4 minus 2 is plus 2. 5 minus 0 plus minus 0 plus 2, that means 5 minus 2 is plus 3. Here 0 minus 0 minus 2, and minus of minus 2 is plus 2, so this will be plus 2. 5 minus 4 5 minus 2 plus 2, that means 5 minus 4, this means plus 1. Here 7 minus 2 plus 2, that means 7 minus 4, that means plus 3. And here 3 minus 2 plus 1, that means 3 minus 3 is 0. Now as we can see here that all the values in the non-basic cell are coming as 0 or positive. This means that our solution is an optimal solution. So let us first calculate the value of z for this optimal solution. So we can see that this is 8 plus 8 16, 420, this is 32, 38 plus 12 50 plus 24 74. So for this value z minimum is coming as 74 rupees per quintal. Okay, this is coming as 74 rupees per quintal. Now it is interesting to see here that among these non-basic cell value, one of the values is 0. So what this 0 suggests is that if I allocate 1 unit in this particular cell, the overall transportation cost will neither going to increase nor going to decrease, because this value is 0 suggests that there will be 0 improvement in the value of z, that is value of our objective function. And this can be compared to the equivalent compared as equivalent to what we have solved in the simplex method. In simplex method we have calculated the net evaluation row, which is Cj minus Zj row, and in that particular row if a non-basic variable is having a value 0, that means it is possible that that particular variable may enter the basis, and we will have a different combination for having the same objective function value. That means for same value of z we will have a different combination of decision variables. Similar is the case here. This 0 suggests that our objective function will not going to change, that means z minimum will not going to change, but the combination may change. So now let us see what will happen if I allocate 1 unit here. So as I allocate plus theta unit here, that means now it has more than m plus n minus 1 number of allocation, and now this will definitely form a loop. So let us find out the loop first. So this can be easily identified. The loop can be easily identified here. So this is the loop it is forming, and to balance the supply and demand, if I am adding plus theta units here, then I have to be subtracting minus theta unit. If this is minus theta, this has to be plus theta. This is plus theta, this will be minus theta. This is minus theta, this has to be plus theta. This is plus theta, this has to be minus theta. Okay, so now the demand and supply are balanced, and we need to find out what will be the value of theta. So theta here is the maximum possible value that can be allocated in this particular cell. That means theta is the maximum value that can be allocated here. So the value of theta can be found out when we see the values in the cell where we have minus theta values, because plus theta can be increased indefinitely and there is no restriction on it. But in minus theta values, we can see that here we have 6 minus theta. That means theta can be increased only up to 6, because if we increase theta beyond 6, this will become negative and our non-negativity restriction will get violated. Similarly, for this cell, this is 2 minus theta. That means we can only increase the value of theta up to 2 and not beyond. Similarly, here this is 2 minus theta. That means theta here can also be increased up to 2. So among these, theta can be 2 here, theta can be 6 here, theta can be 2 here. So the minimum value of theta we can put in this cell is 2. So now let us put theta equal to 2 and see what will be the change occur in our solution matrix. So let us write here, this will be plus theta, that means this will be plus 2. Here 6 minus theta, that means 6 minus 2 is 4, so this will become 4. Similarly here 6 plus theta, that means 6 plus 2 is 8, so this will become 8. This will be 2 minus theta, 2 minus 2 is 0, that means now here in this cell there will be no allocation. Similarly here 2 plus theta, 2 plus 2 is 4, so this will become 4. Okay, this will be 2 minus theta, that means 2 minus 2 will be 0 and there will be no allocation here. So and the remaining allocation are 4, 6, this will be 6 and this is also 6. So we have seen here that we have find out our solution and we have written here the improved solution. So again we need to check the optimality here, and to check the optimality we know that we must have m plus n minus 1 number of allocation which is equal to 8 in this particular matrix, but our allocation has been reduced to 7. Now we have 7 independent allocations, so that means we need to have one more cell potential. We need to identify one more cell which can be used as the independent allocation cell. So let us select one cell. We need to select a cell which will not form a loop. Okay, that is very important. So here I am selecting this cell because this will not form a loop here. Okay, so now we have m plus n minus 1 number of independent allocation, and now we need to check the optimality of this particular solution. So let us again calculate the values of u1, u2, u3, v1, v2, v3, v4, v5 and v6. Now putting u1 equal to 0, 0 plus what equals to 4, so this is equals to 4, 0 plus what equals to 2, this is equals to 2, 0 plus what equals to 2, this is equals to 2. Now 2 plus what equals to 2, so this will be 0, 2 plus 0 is 2. Then 0 plus what equals to 1, so 0 plus 1 is 1. Now 1 plus what equals to 3, so 1 plus 2 is 3, and 2 plus what equals to 4, So 2 plus 2 equals to 4, and 2 plus what equals to 0. So 2 plus of minus 2 is equals to 0. Now we have calculated the values of u's and v's. We need to calculate the values at non-basic cell, and we need to calculate Cij minus of ui plus vj. So let us calculate this. 3 minus 0 plus 2, that means 3 minus 2 is plus 1. Here 6 minus of 0 plus 1, 6 minus 1 is plus 5. Here 0 minus of 0 minus 2, so minus of minus 2 is plus 2, this will be plus 2. 5 minus 0 plus 4, 5 minus 4 is plus 1. 4 minus 0 plus 2, 4 minus 2 is plus 2. 5 minus 0 plus 2, 5 minus 2 is plus 3. Here 0 minus 0 plus 0 minus 2, minus of minus 2 is plus 2. Here 6 minus 2 plus 4, 6 minus 6 is 0. 5 minus 2 plus 2, 5 minus 4 is plus 1. And here 7 minus 2 plus 2, 7 minus 4 is equals to plus 3. Now here we can see that all the values in the non-basic cell are either 0 or positive, and if we calculate the value of z for this particular solution, we will get the value of z minimum equal to 74 for this particular solution also. So we can see that after allocating here, that means at the Cj minus at the value 0, what we are having is a different allocation for the same value of z. That means if we are having 0 at the non-basic cell, this indicates that there is another possible solution which will give us the same result, or we can see the same value of z. So here also we can see that there is still one value is coming as 0. So again if we allocate here, we will get this particular solution. That means this problem has more than one solution, and this is known as alternate optima. Okay, this sort of problem is known as multiple solution or alternate optima. So if you like the lecture, please share the lecture. Have a nice day. Thank you.